Okay, everybody, we got this beautiful question. Check if the function f of x equal to modulus of x cos of modulus of x cubed positive x is continuous at x is equal to 0. Now, I'm going to state the condition. This is the answer to this question. For a function to be continuous, the necessary conditions are: number one, limit x tending to, we are talking about a function to be continuous at x is equal to 0. So that's why I'm starting with limit x tending to 0 of f of x is equal to f of 0. So what is the meaning of this? This means the function as to be defined at x is equal to 0. So it must have a value. Condition number 2, limit x tending to 0 plus of f of x should exist. Okay, so this is called the right hand limit. And condition number 3, limit x tending to 0 minus f of x should exist. This is called as the left hand limit. Condition number 4 is limit x tending to 0 plus of f of x should be equal to limit x tending to 0 minus f of x. The meaning is the right hand limit should be equal to the left hand limit. So all these should be checked. If all these things hold good, this means f of x is continuous at x is equal to 0. Okay? Okay, so having given you this, let me go and provide you the solution for this question by checking each of these conditions. So foremost, I will find out this condition. So f of x is given what? Modulus of x times the cos of modulus of x cubed positive x. I'm going to rewrite this as f of x is equal to modulus of x times cos of, I'm going to take a x out and rewrite this as x squared positive 1 within the modulus. This is further rewritten as modulus of x cos of, I'm going to take the modulus of x out and rewrite this as modulus of x times modulus of x squared positive 1. Now find if the function is defined at x is equal to 0. So what are we trying to do? We are asking, or we are basically finding the functional value. Obtain the functional value at x is equal to 0. So this is exactly what we are trying to get here. Okay? So f of 0 is nothing but modulus of 0 times cos of modulus of 0 times let me write it like this, modulus of 0 squared positive 1. Okay? Now modulus of 0 is 0, cos of modulus of 0 is 0, 0 positive 1, 0 times anything is going to be 0. So cos of 0 times modulus of 0 will give us 0. So f of 0 is equal to 0 implies functional value is defined. Of course you can say it exists at x is equal to 0. So that is fair and well. Now let me go to the second stage. So what is the second stage? Find limit x tending to 0 plus of f of x. Now if I were to take f of x is equal to modulus of x, now I'm going to study this value modulus of x. Now this is defined in the following manner. It is equal to x for all values of x greater than or equal to 0. Okay, this is the definition, we have to look into it. So with this in mind, my f of x is equal to modulus of x times cos of modulus of x times modulus of x squared positive 1. So what will this take for all values of x? So indirectly what I'm asking you is what happens to the function when x is tending towards 0 from the right hand side. So you have this number line and 0 is present here. So we are moving towards 0 from the positive end. So clearly modulus of x is going to be equal to x cos of x. This is clearly going to be a positive value, right? So this is going to be x squared positive 1. So this is exactly what we've got as the function. So now if I'm going to tend towards 0 plus for this function, what would this be? This would be limit extending to 0 plus of x times cos of x times of x squared positive 1. So clearly this is going to be equal to 0. So this is my right hand limit. Okay, moving on. I am done with this. So let me go to the next part. So what is the next part? This is the left hand limit. So we are actually finding x tending towards 0 negative of the function. So this is going to be equal to limit extending to 0 minus the function is given to be as modulus of x times cos of modulus of x times x squared positive 1. Now let me define this function. F of x is equal to modulus of x. Now this will take negative x for all values of x less than 0. So that would mean this is going to be limit x tending to 0. The modulus of x is going to be negative x, isn't it? So that value we need to put in place there. So this is going to be negative x cos of negative x. This is going to be positive. So just write that as it is, x squared positive 1. And cosine is a even function. That means cos of negative x is equal to cos x. So this is going to be limit x tending to 0 minus negative x times cos of x times x squared positive 1. Now applying limits as x tends to 0 minus from the left side, applying limits we get. So what do you get? This is going to give me 1, but this will give me 0. So 0 times 1, which is equal to 0, which means limit extending to 0 minus of f of x is equal to 0. So if I were to take this as 2, and if I were to take this as 1, from 1 and 2, we get limit extending to 0 plus of f of x is equal to limit extending to 0 minus of f of x. The right hand limit is equal to left hand limit. Now go back to the first page of the solution. Now clearly we have shown the functional value. If I were to write this as sum a, since from a we know f of x at x is equal to 0 exists. Thus from a, from 1, from 2, or I would say I will give this as b, say from 1, 2 and b, we conclude that f of x is equal to modulus of x times cos of modulus of x cubed positive x is continuous. So that is the conclusion for this beautiful question. Please like, share and subscribe. Thank you everybody.